Okay, so we're taking a look at number 3. We've done the regression. We've put the data in the calculator already, is where we're at. And so, thank you. So we've put the data in the lists here, and we've turned the stat plot on. We're drawing from list 1, 2, and it's a scatter plot. We've graphed that. We've also done stat over to calculate quadratic regression right here, quad reg, list 1, comma, list 2, comma, y1 to put the equation in there. So what I want to focus on here in this little next part here is finding the answer to this question: when did the ball hit the ground? And so the height in meters is the height of the ball above the green. Oh, it does say there, above the green, given in the table. So it hits the ground right here at the x-intercept. Okay, so how do we find the x-intercept? First of all, what I'm going to do is I'm going to move my y minimum down a bit so I can see this a bit better. Let's go to minus or negative 2. So we can kind of see the x-intercept there. Is that working? Okay, so this is when the ball hits the ground at this particular time. Now you could just hit trace and you could cursor over, but the problem is it's going to just pop from point to point. Okay, if you do this up cursor, it will now flip to the function. So if you want just a ballpark, you could try and do this and just trace along until y gets to 0. The problem is that you might just blow right by 0. You see, y equals 4.7, and then all of a sudden y equals negative 0.5. So hitting exactly 0 with the trace might not work. So this is how you do it. You want to go to second function here, trace, which is that calculate menu. That calculate menu is pretty important for a lot of things. But the 0, here you see the 0? That's going to represent the 0 or the roots of the equation or the solutions. That's going to be the x-intercept or x-intercepts. So that's one thing we can do. So let's do number 2 and tell the calculator we want to find the x-intercept. Now, it's a little tough. I've got these numbers here. I can't really see the x-intercept, but the x-intercept has to be on the screen somewhere. I'm just going to pop back up here to these little notes right here. How to find the x-intercept on your graphing calculator. Make sure you can see the x-intercept on your screen. Now, like I say, with these little numbers here, I'm actually going to change the window even more so I can see that a bit better. So I'm going to go -5 maybe. And so just brings that x-axis up a little bit more. That may or may not work, but let's see. Second function, calculate. Let's do the 0 again. Yeah, slightly better. Now, this is what happens. Left bound. You see when it says left bound? You're going to see left bound and right bound. You want to put the cursor, so here's the blinking cursor right there. You want to put that just to the left of where the intercept would be. So if we have something like this, you want to put the cursor just to the left of where this intercept would be right here. Okay, and then you'll have kind of a left boundary. And we want to tell the calculator, hey, this is just to the left of the intercept I want you to look for. So just hit enter when your cursor is there. Now it'll say right boundary. So you want to just cursor over to the right until you get a little bit to the right of the intercept. And how do you know? You're going to be in negative y territory there, if you can't quite see it. And then you hit enter again. You'll have these two little arrows pointing at each other. And that means we've told the calculator that I want to find an intercept, an x-intercept, in between those two arrows. And this is exactly where this x-intercept is going to be. And then it'll say guess, right? And so it says enter the guess. It'll say guess. And then you say yes, please. And then it'll say here's the 0. When y equals 0, this is the x value. And this, for this question, is going to be the time when the ball is at a height of 0. Oops. So when the ball is at a height of 0, that's when, when the ball hit the ground is the time when height, or the y value, is 0. And again, according to our graphing calculator, it says that when the height is 0, the x value is 5.31. And so because x is our time, it's going to hit the ground. The d, when does the ball hit the ground? at 5.31 seconds. Okay? So understanding what the x-axis means in the question, right? That's time. And what the y-axis means in the question, that's the height of the ball above the green. So we're assuming that the ball hits the ground when it hits y = 0 height. And that's how you find it. Okay, any questions?